Welcome back to our course of trusses. We will consider the subdivided truss or Baltimore truss here. Using the second method of analyzing the truss using subdivisions, we can simply consider our truss to consist of two trusses. The first is the main truss here with the supports at A and B and the previously computed reactions, and the joints numbered in brown, plus the secondary trusses here. If we add the main truss and the secondary trusses, we will get our original truss drawn above. Considering the loads, we will have them once on the main truss and another time on the secondary trusses. Starting with the main truss, we have no problems with the loads 10 tons at joint 3 and 10 tons at joint 7. But the 6 tons here are not truss loads as they are applied directly on the link members and not on the joints. So let's have them on the bottom chord and divide each load of them equally between the adjacent joints. Here we can get rid of the 6 tons, but first let's add the 3 tons at joint 4 to have a 6 ton, and by this way we compensated for the 6 tons on the link members by forces on the joints. Considering the secondary truss, we have our loads on joints 10 and 12. Those secondary trusses can be considered separate trusses. Can be considered really 4 separate trusses. The first one and the last one have no external forces and therefore have reactions zeros, green reactions. The second and the third truss here have 6 tons each at the top joint, and therefore each 6 tons give 3 tons reactions at each support. We consider the bottom chord here to have supports at the reactions. Now, if you add this main truss and the secondary trusses together, we will get the original truss. The 3 blue tons at joint 2 here will really cancel the 0 and the 3 tons drawn in green for the secondary trusses. Also at joint 4, the 6 blue tons on the main truss, we will cancel the 3 green tons drawn on the secondary truss. And we will be left with the 6 tons here at joint 10 and another 6 ton here at joint 12. Considering the first secondary truss here, reactions at joint A and joint 2 are zeros, and therefore all internal forces drawn in red here are 0 tons. For the second secondary truss here, we have a 6 ton at joint 10 and the reaction green 3 tons at joints 2 and 4. Considering joint 13, we can simply conclude that the vertical member here is a 0 member. Considering joint 2 and sigma forces in the y direction equals 0, we can simply conclude that member 210 is a compression member with a force 4.24 tons. This secondary truss is symmetric, and therefore member 10 4 has the same force in member 10 2. Of course, we would have concluded the same forces by taking joint 10 and considering sigma forces in the x direction to conclude that the two inclined members have the same force, and then considering sigma forces in the y direction to conclude that each vertical component of them has half the 6 tons, which gives that the force in the inclined member is minus 4.24. Of course, the horizontal member 213 can be easily concluded from considering joint 2 and equilibrium in the x direction, taking the horizontal component of the force in member 210 and the internal force in 213 concludes that the force in 213 is 3 tons tension. This is the concept of dividing the Baltimore truss. The second lecture, we will get the internal forces in the main truss and the internal forces in the secondary trusses, and we will learn how to add them together to conclude the forces in the original truss here.